Welcome to KMIT Vista. In this today's session, we will be studying our fourth unit in AI technologies and applications. Here in this fourth chapter, we have completed different applications like soil management system, smart irrigation system, weather forecasting, agriculture drones and agriculture robots. Today we are going to see our next topic, tackling the labor challenges and driverless tractors and crop sowing. These are the applications that are designed automatized AI ML based agriculture models. First what is in last session we saw what is a robot and what is a drone. Robot is a land rover or land rowing vehicle where it moves on the ground, whereas drones are the unmanned aerial vehicles where they observe the agriculture farms or the lands, so that we have to design the robot and the drone. So today we are going to see how to tackle the labor challenges. So when we are using robots and drones, we are doing automatized and reducing the labor power, so that we are improving the yield of the agriculture. So here for tackling the labor challenges, building an AI solution to tackle the labor challenges in agriculture involves in leveraging various technologies to automate and optimize the tasks traditionally performed by the human labor. So what are the tasks that we have to tackle is determine which agriculture task you need to automate and what are the tasks that can be reducing the labor challenges. So first one is crop monitoring system using drones and AI which can monitor the crop health. Next is we can tackle with the labor is weeding. So using robots we can identify and remove the weeds. Next one is our harvesting, automating the picking and sorting of the crops or the fruits. So next is vegetables. So next is the planting. Precision planting uses robotic planters. So these are all the tasks that can be reducing the labor costs. Next, coming to the building AI model for driverless tractors and crop sowing. So we will merge both the driverless tractor and also crop sowing. We can build a small automatic row with a rover. Building an AI model for a driverless tractor and crop sowing involves integrating different components, including computer vision for navigation and object detection, sensor data for environmental awareness, control system for precise movement and operation. We can see the step by step. The first one is to identify the task and the requirement. What are the tasks that we have to do in the driverless tractor and for crop sowing? When we wanted to design, first we have to design identify the problem statement or the tasks and the requirements. First, for designing driverless tractors and crop sowing, first navigation is very important. How to navigate the driverless tractor and the how to sow the seed or the crop. Navigation, ensuring the tractor can move accurately within the field. Second one is it has to detect the obstacle detection, identify and avoid the obstacles. Second one is precision, by accurately it has to sow the seeds in a optimal locations and the depths. Next, here we can see a smaller vision and sensor based autonomous seed sowing robot, where we have the suspension unit. Second, we have the ultrasonic sensor, we have a vision sensor, we have a seed sowing unit, and we have the microcontroller. In this microcontroller, the microcontroller takes all the inputs of the ultrasonic suspension unit, vision sensor, and the seed sowing unit. It takes all the inputs and start predicting the depth of the depth and the optimal point where we need to plant the seed. So by vision sensor, they can observe, it senses all the images or the vision, and it sees whether there is an obstacle or not. By ultrasonic sensor, it always calculates the distance or the depth where the seed has to sow. Next, coming to the how to design this. So to design this, to design the driverless tractor and also the crop sowing, always we need to have the data sets. So to have to automatize the model, we need to create our own data set. So first one is we have to collect the images and the videos that can be captured by the vision sensors mounted on the tractor for navigation and obstacle detection, and GPS data for accurate positioning, sensors data, lidars to examine the surface, sends the lights and reflects the object and captures the scene of the data. Next is ultrasonic sensors. Ultrasonic sensors measures the object distance and also the velocity. Soil sensors observes the environment and mapping and calculates the mapping and planting. Next is operational data. Once the data is collected at present, the past data is also required, which is nothing but the historical data on sowing patterns and also yields of the crop. Next, after collecting the data, we need to pre-process the data. We know that if the images are there, we need to resize the images. Next is normalize the images according to the model. Resizing the images is required when we are giving for different models like CNN, LSTM, object detection, so on, and augmenting images to increase the data set size. So GPS and the sensor data is always been cleaned and normalized and synchronized with the image and video data. Next, labeling is very important in crop detection or recommendation system. So always we need to annotate the images for navigation and obstacle detection. Next is after collecting the data from all the sensors, pre-processing all the data, we need to choose the model selection. So to design the crop sowing and also the driverless tractor, always we need to improve the navigation and obstacle detection. For this we can use CNN for image classification, and for object detection we can use YOLO or faster RCNN, so which can improve our accuracy of detection of or classification. Next is precision sowing. So precision sowing always should calculate the depth. Depth means the distance, which is nothing but it is a regression model. To calculate or predict the depth, always it has to have the regression model for determining the optimal sowing locations, and also the path planning algorithm for controlling the tractor movement. Once the model is selected, model has to be trained per epochs. Once the model is trained, we need to evaluate. So we have designed here, first one is the classifier, second one is the detector, object detection, third one is the regression for calculating the distance or the depth of sowing the plant or the crop. So for this we need to calculate for classification and detection, we calculate accuracy, precision, recall, F1 score and the map, and for regression we calculate MSE and MAE. Once the accuracy and the errors are very less, if the model is working properly, we can integrate the model with our HTML code or REST API, or we can also merge with Django and deploy the models in appropriate frameworks. So like web applications or edge deployment or scalable solutions. So in web applications we can merge with Fast API or the Flask. In edge deployment normally we use with the TensorFlow or NVIDIA Justin CPUs. Once the deployment is done, always we need to see whether the driverless tractors and crop sowing are working properly. So if you are if they are not working properly, we need to create a control system to correct the model. So always integrating the AI models with the control systems of the tracker. So what are the control systems required? First one is path planning. To move the driverless car in a track, always we need to have the path planning, or it has to create an optimal solution, so that we need to find out the shortest path. So we use A star and Dijkstra route algorithms. Next is control algorithms. Here we are using proportional integral device controllers. For advanced methods like model predicting the control precision movements. Next is sensor fusion, combining all the data with multiple sensors like camera data, lidar data and GPS data. When we are merging all that, we need to get an good accuracy. This is how we are trying to build our AI and ML based driverless tractor. There we are merging both hardware plus software. So hardware is used to process the data or collect the data with from all the sensors, and the router algorithms are also very important, which can merge into or loaded into the Justin Raspberry Pis or Justin processors or Raspberry Pis. This is how we can build our driverless tractor and also crop sowing system. Thank you.